So good to be here. Um, we spoke about speed, and Anna, you summarized it beautifully. And I will very briefly set the context here with what we are doing on as part of the Green Deal on the circular economy. And this quote from our president is quite important: a regenerative economy, an economy that gives back more than it takes. We are very far from that. Our current circularity rate is a staggering 12%, and it's stagnating. So there are challenges for the advanced materials community. We have to put all this into a more geopolitical context than ever. I'm a fan actually of the Euro Nano forums, and the last one, 2021, where Lars Montelius said it's all about people. I think, and we were always also looking at the big societal questions. Perhaps today would be, it's all about speed. It's all about getting to circularity, reducing our dependencies. And that is the objective of this net zero industrial plan with 2 legislative acts we as Commission have proposed. And the Net Zero Industry Act is about a category of the key products for production of renewable energy, wind, solar, heat pumps, carbon capture and storage as well, actually, where we give special conditions, speed in the regulatory permitting process, by the way. But the average today, we looked at the EU average, is about 10 years for a big installation, for instance, in mining, it's even more. And we want to bring this down to 1 year. You may argue it's not fast enough, but we're working on the speed there. And the Critical Raw Materials Act. I think all of you here know the key figures, how much we depend on imports of cobalt, for instance, of other materials which are crucial for our net zero technology. So the Critical Raw Materials Act sets very specific targets for us to extract, to mine, to process, to reduce, and to recycle, to reduce our dependencies. And of course, research and innovation is in the center of all this. I would briefly like to highlight how important advanced materials have been in the Nobel laureates. Roughly 20% of the prizes are related to, for physics and chemistry, are related to advanced materials. Linnea, you mentioned graphene. Yes, you mentioned graphene. I mean, the Nobel Committee had this nice saying, carbon, they said when they gave the prize to Andrei Geim and Konstantin Novoselov, carbon, the basis of all known life on Earth, has surprised us again, they said, with a 2-dimensional new material. We have here the blue light, the LED. So difficult to find this blue light, which is now at the origin of an industrial revolution, and of course for energy storage in chemistry, fundamental. So our science is a key for advancement in advanced materials. A quick look at our competitive edge. And you see here on the left, you want to be in the big blue bar, that's Europe. You see here that advanced materials, we are quite good, second only to Japan. If you look at these 16 technologies, we are not in a leading position very often, only in advanced manufacturing, notably. On the right side, we want to be in this dark blue bullet that's looking at 10 cross-cutting technologies. Also, again, here, we are quite good on the next generation materials, advanced materials in production. Adoption is also, and I'll come to that, we discussed it this morning, a key challenge. If we zoom in on materials, we are really good in patents, as I mentioned. The adoption level, it plays a key role. You see here 22% of companies, manufacturing companies, use advanced materials. That's not so bad. In skills, we are certainly leading, and in venture capital-backed startups, you see that we still have a long way to go. So important also to keep this leading position in technology adoption and production. So I want to really spend a bit more time, 4 minutes, 6 minutes remaining, on this coordinated plan of action on advanced materials, which we announced when we adopted back in March this Net Zero Act and the Critical Raw Materials Act. These acts focus on reducing our dependencies and getting more access to the materials, the resources, the raw materials. They also speak about circularity, address circularity, but only to a certain degree, because the focus is different. But when we presented this act, the Commission announced that it would present a coordinated plan of action for advanced materials. And the genesis of this is in this Materials 2030 manifesto, which has a very, very nice vision. And you see here it is also encompassing inclusive, blue sky research until market introduction. The vision is of an inclusive European society which is sustainable and circular, and that this happens through cooperation of downstream and upstream producers and actually citizens. So very, very broad approach. That's the vision of this behind the coordinated plan of action we have in mind, which is under preparation. So the objectives are to develop this coherent and inclusive materials ecosystem in Europe. We spoke about cooperation. It is about that cooperation, and to keep our technological leadership as much as possible, and to share the benefits. And the intention of this plan, the objective, is to come up with investments which are commensurate with the challenges. And that is something we copied, actually, from the coordinated plan of action on artificial intelligence. And I have to underline this. It's not everyday business that in Europe we speak of a coordinated action. It's actually a taboo, it's a no-go, because we want to do something together, but no one wants to be coordinated. But on artificial intelligence, the pressure was such, we saw what other regions of the world are investing, and what we are investing, that we said we can only keep our position if we coordinate what's happening at regional level, at national level, and at European level. And exactly this is what we want to do with advanced materials. So the approach is global, is broad, inclusive, and building on all existing initiatives, bringing them together. So here's my clear plea. No one should be feeling left out. It's an inclusive process which we want to drive with this coordinated plan of action. So at this point in time, we hope to present it early next year. So this is early thinking, and this is why I want to make sure that you consider this as not as a firm commitment, it's our current thinking, it's a draft. So we see 6 main line of actions for such a plan with 18 concrete actions in it. And of course, the first and foremost is what I mentioned, the alignment of strategies. We would be much better off if every member state, that would be first objective, had a dedicated advanced materials strategy. We would be much better off if there was an agreement on the overall direction, the objectives and the needs, and who contributes with which action to which part of it. I mean, that would be quite powerful. And we have a strong ecosystem. We have also this competitive edge. So bringing in the key future, the key ongoing and future initiatives in such a plan. And very important is that we, from the beginning, have an, let me call it a return on investment strategy, that we look at the market perspectives, that we can bring in the capital where we are so weak when we look at the current situation. Of course, all this, I would like to underline this here, let's not create another regrettable substitution here. Let's try to be safe and sustainable from the very beginning. When I look at the Net Zero Act, I mean, currently the solar panels are hardly recyclable. For the wind blades of the windmills, neither. So that we do have a real challenge, and the safe and sustainable by design is a central element of our success. And of course, digitalization and materials. This was a question this morning also on data sharing. This plan should work towards materials commons, a common place for the benefit of all. Of course, with different layers of access depending on your own role and what kind of objectives you have. Not everything is benevolent or well-intended. But such a, if we imagine that we could produce with new computing powers, energy efficient, of course, water cooled or air cooled, if we could produce and model over a weekend 100 new substances, it's not so far from possibility today. But if we were able to predict the properties of these materials, I mean, that would be really fantastic. And for that, we need to work on data and characterization and modeling together with a lot of power. So remember, it's only a draft. Second area of action is about accelerating uptake. And I've taken a lot of encouragement and good ideas from today's discussion, right now our discussion on making this uptake faster. Talent is a key. We cannot do this without continuous up and reskilling. And we have a good partner with the European Institute of Innovation Technologies and the knowledge innovation communities there, and the academies funded. So in science, it's clear we can only thrive with strong international cooperation. I mentioned Japan before as a patent leader. With trusted companies, trusted third countries, our wish is to cooperate. The EU is building a lot of partnerships, not only on energy but also on critical raw materials with trusted partners, and the international dimension should be equally strong here. Draft. So, timeline. So we would like to present it not too late next year, and have the right governance set up. And before that, we have several occasions to discuss with member states. We have already started this discussion in different format. We will look at together with the European Research Area and Innovation Committee later this month. We had already a good discussion with the program committee, and many colleagues from that program committee are here. We would like to do and are certainly going to do an outreach event in October. If some of you or one of you would like to do such an outreach event, please connect. We'd be delighted to engage and then adopt it in Q1 2024. This last slide, we didn't share our presentations, Anna, and yours was much nicer. But I chose this picture of the planetary boundaries, because it's quite new, has just been published in Nature, and it's new in the sense that it includes social science and humanities in a way which was not present in the safe transition and just transition, which might be the next big challenge. Once we here and you with your collective intelligence have solved the problem of climate change, might be the next big thing we have to address in order to succeed. Thank you very much.
All right, thank you, Peter. So we're running over schedule, but for the next few minutes, probably no more than 5 or so, we'd be happy to take questions from the audience. Any topic, no thought too small, too large. Sir, right over there.
Yeah. Okay.
A lot of tables in front of.
This question for you, Peter. How do we define circularity, and how would we quantifying it, particularly in terms of energy uses and resource uses? Because it's very unclear to lots of us. I'm an engineer, I know how to calculate efficiency, but I don't know how to calculate circularity. And this is quite important.
Thank you for this question. So currently it's a quite basic calculation, material input versus material, so included imports, exports for recycling are deducted, and then you have the sum of what is remaining. So it's a rather basic definition we have. We have in our European Action Plan for the circular economy a bit more sophisticated picture, but we don't have the single measurement quote, which I mentioned, the 12%, so that is still more basic.
Okay, other questions in the room? Sir, up there. All right, I'm going to do the baton race.
Thank you very much. My name is Stem Voss Hansen. I'm from the Technical University of Denmark. I was wondering, in regards to the diversity of materials or advanced materials, which is very broad, I was wondering, does it really make sense to have one strategy that covers such a diversity of materials?
I don't know, how many do you want? I think it makes a lot of sense to have an all-encompassing overall approach, which is inclusive. And we might not include the right materials research at the very beginning. They may join up later. But given the challenge we want to achieve, given the big questions, we need cooperation across all disciplines. And I wouldn't want to separate and create silos within the materials community. So actually one of the implementing tools we're considering would be public-private partnership at European level. And one of the elements we want to include there is two-dimensional materials, which are currently part of a separate initiative at European level, what we call a future emerging technology flagship. Integrating that, for me, makes a lot of sense, would make a lot of sense. So I would rather see a case for integration rather than for separation.
Just a comment as a, it doesn't work, yeah. Just a comment as a policymaker prior to this. Sometimes you need to simplify things when you are on the policy side, and I think that also makes sense to have one strategy, and then you can learn from across different sectors, different disciplines again, but make it not too complicated on the policy side. Because I've seen that normally the policy or the regulations sort of build upon each other, and after a while it doesn't make sense. So coming together in a common strategy, but that was just an experience from being a policymaker. It makes sense with one strategy, even though it's hard to really formulate it.
To our speakers for providing all this fantastic information and some of the insights into the way that you're thinking about things. So, round of applause. Thank you, everybody.